Data structure using C++, hash table representation, session 2. So hash table representation is used to effectively search for a key present in a dictionary. So there are other techniques, linear search and binary search, but it takes time. Already this was discussed. So some of the terms also which we had discussed in the previous class are buckets, home buckets. So again, let's recollect this. What is a bucket? Bucket happens to be a space created in a table. What is this table? Table will be the space created for a particular operator. If your hash function has an operator like d, and if that d value is defined as 11, which you can have a look at, in this case d is 11. So based on the d value, you have to create a table with that dimension. So once you create a table with that dimension, here you have 11 spaces is created. So this each space in this table, you call it as a bucket. So bucket happens to be a space created in the table, and the space is created for the key which you are going to search for. So for that, the space is created here. And here, if we consider initially that there are 3 keys which we need to look for or search for or insert for or delete for, then first of all we need to check whether that key is available. So what you do is you just go to table of so first the position for this particular key, if you want to trace it, is 80% 11 operation you perform, you get reminder as 3, and at the third position the key will be stuck. That's what the concept is. And again this is 7 because we again perform 40 percentage 11, so you get 30 33. 7 is a reminder, so 7th position 40, and figure finally this is for the key 65. So this the position for a particular key in the hash table, you call it as bucket. I repeat, the home bucket is actually the position mapped for a particular key in the hash table. That's how you define a home bucket. And you can figure out that different keys can be mapped to the home bucket in the hash table, because there is a chance that when you compute one more value, like if 55 is one more key, 58 is one more key, and when you compute 58 modulo 11, definitely you're gonna get the reminder as 3. So already in the position 3 you have 80. Also at the same position, using some hardware technology or hardware stuff, you have to push the second pair in the same space, same position. One more pair will be pushed here, but for the time being we consider that this bucket, each bucket can create only one space for a pair of a dictionary. For a pair in a dictionary, one pair you can add in this space created by this bucket. So no privilege to add 2 pairs, hence there is a overlap here. But literally home buckets could be filled. The capacity of the home bucket could be maximum. It depends on the key, and also it depends on the D. So this was already discussed. Just for recollecting, we have addressed this again. The next question arises: what should be the concept of hash function? Uniform hash function was also discussed. Almost all the spaces occupied in the table should be equally filled. The capacity of every memory space which has been reserved for filling up the key should be distributed equally. You cannot afford to create an empty space, and also you cannot create a space wherein more keys will be mapped onto that position. Then we will look at what should be the selection of D. Selection of D. Whether it should be a even number, whether it should be an odd number, what exactly it should be, and how it is going to change the status of the key. So this example, this concept is for selecting the D value. So we will consider one example wherein the D value is considered as 10 and the D is even and the K values are all even numbers. So if this is the case, then initially we perform here the hash function is f of k is equal to k percentage t, 10 percentage 10, you get 0, 0th position 10 is stuff, Again 26 percentage 10, sixth position 27, 26 goes. Then you have 24 percentage 10, fourth position 24 sits. Then you have 16 percentage 10, sixth position. uh, Again 16 value will be stuffed here, but we don't have a space here, so there is a collision, no problem. But if there is a privilege for a bucket to store more than one pair, then you can afford to have this number at this position. Okay, and finally you have 8 and 12, so 8 is here and 12 is here. So finally we can figure out that the odd maps or odd positions are empty, whereas the even positions are filled. So this scenario, we can say that the memory structure is not optimal, which means all spaces are not equally filled. Some are filled, some are not filled, and you can see that the even positions are completely filled, but the odd positions are not filled. So this arises for the situation when the key value is even and also when d is even. We have next case when the value of key as odd and also when the d value is odd, then again same scenario arises. So even positions will not be occupied at that case, but the odd positions will be occupied. So that again is not a better technique to map a data into this table. So next that's the stuff. So the solution is one solution for addressing that problem is select the d to be prime. Select d to be prime. When you select d as prime, then we can avoid this stuff. So we can figure out that d was considered as 11 and it was solving the problem which we had encountered. The next concept which we'll be discussing is a program which is used to provide a string value. It is going to convert a string value into an integer, and the method which it adapts to convert a string into integer, it does this. So it will calculate what is the length of the string first. So once you evaluate the length of the string, then if it's odd, then we perform this step. If it's even, then we perform this step. And if it's odd, then the length will be decremented by 1. When the length gets decremented by 1, if the length happens to be odd, then definitely you are forcefully making its length even, then this instruction will be executed. Suppose if the length is not odd, then directly you go back here and work upon this instructions and you're gonna get the result. Okay, and this program does what? Let's address. So first assume that the string is abc. Abc is your string, and we have the length as defined s dot length. So s dot length is gonna give you for the string abc, the length is 3. The string size is 3 here, so length is gonna give you a value 3. And we set the value of answer which has to be returned back. We set the value of answer as 0 first, then we calculate this stuff. So first evaluate length modulo 2. What is the value of length modulo 2? Now the situation is length is 3, 3 modulo 2 returns 1. So when it is returning 1, evaluate this. So answer is equal to s dot at of length. So we have discussed what is this function s dot at of. So s dot at of 0, it is the ASCII value of a. S dot at of 1, ASCII value of b. S dot at of 2 have ASCII value of c. Now you have s dot at of 2, length minus 1 is 2, so s dot at of 2 is gonna give you the answer which is of data type integer, and that value is equal to 99. C, its ASCII value is 99. After this we decrement the value of length and the length value becomes 2 now. Then we proceed with this. So now answer is 99. Then we perform this iteration for int I is equal to 0, I less than length, I plus is equal to 2. So after performing this statement, I jumps in steps of 2. So first you have answer is equal to answer plus s dot at of I. So I is equal to 0. You have answer is equal to answer plus s dot at of 0. So you have 99, which is the previous content, plus s dot of at of I you have at of 0, 97. So 97 plus 99 you get 196. Then same value of answer will be considered, so you have answer is equal to answer plus, so you get 196 plus, process this. So for I0 you get s dot I plus 1 as 98. So 98 you shift it by 8 position. It is also equivalent to multiplying the value 98 with the 2 to the power 8. So multiply 98 with the 2 to the power 8, you will be getting 25,088 as the result. Add 25,088 result with the previous content of answer, which is equal to 196. So the ultimate result which you're gonna get it in the variable result is equal to 25,284. So after this I will not repeat again, because I value reaches 2, and 2 is not less than 2. So this is false. So ultimately you go here, you have return of check value of answer, what it is. Answer value is greater than 0. You have 25,284. So return the same answer. If the answer is false, then you have to return negative of answer. So this makes the number positive always. So even if this is negative of answer becomes positive, so you get a non-negative integer. Non-negative integer you will be getting. That's the concept of this program. So this program I'll upload it in the Moodle. You can refer, you can run the program. A working code will also be attached with this. The final code for today, which is the hash. This is the hash function. So the argument which the hash function takes, hash is a class now, and this hash is going to take the argument as string. So you have to pass the string as an argument to this function hash. And so here in the public domain you will be defining one operator that is parenthesis. So which means this parenthesis for the hash function you define, and the argument which you'll be providing inside this parenthesis is the string. So you have to define a string first in the main program. In the main program define a string, and that string data has to be passed as an argument to this operator parenthesis. So that's what is defined here. So let's discuss what is this operator doing. So this operator, that is parenthesis operator, does as follows. So first it will set the value of hash value is equal to 0. Then we define length is equal to int of the key dot length. So the key is your string value. The data type of the key is string. Assume key is ABC again. That's a string. Okay, so the length of the key, which is ABC, is 3 now. Okay, and iterate this. So we check for int I is equal to 0, I less than length, I plus plus, evaluate this expression. So previous content of hash value was 0. Now you write hash value is equal to 5 times hash value. So 5 times 0, this is 0, plus the key dot at of I. So I is 0, so the key dot at of 0 position, you have the first ASCII value, a ASCII value. A ASCII value is 97. So you'll be getting hash value as 97 initially. But the iteration is not stopped, so it returns again. Again I will become 1. So now the previous content of hash value is 97. 5 times 97 becomes your result, and that result is equal to 583, and that will be added with the key dot at of 1. So at of 1 you have 98. 98 gets added with 5 times the previous content of the character, which is a character ASCII value. So 5 times 97 plus 98 you get. So this gives you the value 583 now. Okay, 583 will be the result. Again I will be incremented. I becomes 2. Hash value becomes 5 times 583. 5 times 583 previous content of hash value plus the key dot at of I. So now this is 99. So final work will be 5 into 583 you perform plus 99 you add, so the result will be 3014, and this value in the hash will be returned, and the data type of hash value is unsigned long, and this size underscore t is a special structure. You can think as if this is a data type, so it can behave as integer, it can behave as whatever data type you address here. So here it is going to return the data type of hash value itself, and its value is returned back using size underscore t. So this is a class, this is a special class which can return data belonging to any data type. So here the hash values data type is long, unsigned long, and same the value along with that, its return type is known to with the help of size underscore t, and it will be returned back. So to use this in the main program, you have to create first a class named hash, and you have to define the object for the hash. Then we will be using the object. Within the object, using parenthesis, you can pass the string, and you can use C out instruction in front of it, and that's how you will be getting the converted integer for this particular string. Again, this program too, the full working code for this program will also be uploaded into the Moodle. Have a look at the whole code, and if any confusion, clarification, you can discuss with me. For the time being, we will discuss this much, and the last concept in this hash function is linear probing, which we will discuss. Already you know linear probing is a method used for resolving the collision, and how the collision can be resolved using linear probing, and how linear probing algorithm works we will discuss in the next class.